In previous class, we already discussed epsilon delta definition of continuity together with its geometrical interpretation and some important example of continuity. Now, here we are going to discuss when a function is said to be discontinuous at a point x equal to a, and what are the type of discontinuities of a function. Before going to discuss about the discontinuity, we write here the definition of continuity in symbolic manner. If a function fx is said to be continuous at x equal to a, then we write limit x tends to a fx, this is equal to f of a. That is the limiting value and the functional value are same. And for existence of this limit, we also know that the left hand limit and right hand limit must be equal. That is, from here we can write f of a plus 0, that is right hand limit, is equal to f of a minus 0, that is left hand limit, and this is equal to f of a. This is the functional value. These three must be equal for continuity of f of x at x equal to a. Now, if any one of these condition, like if right hand limit does not exist, or if right hand limit, left hand limit exist, but these are not equal, or right hand limit is equal to infinity, so many cases arise, and these are the types of discontinuity. And the definition of discontinuity, we say that if this is these three conditions, at least one of these three conditions not hold, then the function is said to be discontinuous at x equal to a. Now we start with the type of discontinuities. Let right hand limit and left hand limit both exist and both be equal. Okay, that is the limit exists. But if this is not equal to the functional value, then this is a type of discontinuities, and this type is known as removable discontinuities. Removable discontinuities. Because this type of discontinuity can be removed by assuming f of a is equal to f of a plus 0 is equal to f of a minus 0. For example, we let fx equal to x square minus 4 by x minus 2. Then clearly f of 2 does not exist. Does not exist. Because if we put x equal to 2, then this is 0 by 0 form. So this is does not exist. But limit x tends to 2, fx, it is 4. Because x minus 2 cancelled from numerator and denominator, and they are only left factor is x plus 2. So the limiting value is 4. So if we assume f of 2 equal to 4, that is the function is defined as fx equal to this for x not equal to 2 and this is 4 for x equal to 2, then the function is continuous at x equal to 2. So this function has removable discontinuity at x equal to 2. Now if f of a plus 0, that is right hand limit, and f of a minus 0, that is left hand limit, both exist but these are not equal, then this type of discontinuities is called first type or first kind discontinuity. For example, if we take fx equal to mod x by x, and we know that limit x tends to 0, if we consider the point 0, then mod x by x for right hand limit, this is limit x tends to 0 x by x, this is 1, and limit x tends to 0 minus mod x by x, this is limit x tends to 0 minus x by x, this is minus 1. So right hand limit is 1 and left hand limit is minus 1. So this is discontinuous at x equal to 0, and this type of discontinuity is called first type of discontinuity or first kind of discontinuity. Also, if f of a exists, okay, let this is equal to k, this is equal to p, and this is equal to c. Right hand limit is equal to k, left hand limit is equal to p, and functional value is equal to c. If p equal to c, that is left hand limit and functional value is equal but not right hand limit, then we say that this type of continuity is first kind continuity from the right. Similarly, if k is equal to c but this is not equal to p, here this is not equal to k, then similarly we say that this type of discontinuity is discontinuity of first type from the left. Okay, so this is first type and this is first type from the right, from the left. Now if any one of f of a plus 0 or f of a minus 0 or both does not exist, then this type of discontinuity is said to be discontinuity of second kind or discontinuity of second type. If we consider an example, fx equal to sine 1 by x, x not equal to 0 and this is 0 for x equal to 0, and we know that this limit x tends to 0 plus fx or limit x tends to 0 minus fx, both does not exist, right? So this type of discontinuity is the second kind of discontinuity. If right hand limit exists but left hand limit does not exist, then we say that this is second type discontinuity from the left. Similarly, if this does not exist but this exists, then we say that the discontinuity from the right. For this example, we say that sine 1 by x or cos 1 by x, this both function, take infinitely many values between minus 1 and 1 in any interval. Take infinitely many values between minus 1 and 1 in any interval So this type of discontinuities are also called oscillatory discontinuity. This is also called oscillatory discontinuity. F of a plus 0 is equal to k. F of a minus 0 is equal to p, and f of a equal to c. These three are different. Okay, so obviously this is a discontinuity of first type, because this exists but not equal. Then we say that this type of discontinuity as jump discontinuity. And we measure the jump or right jump as mod of f of a plus 0 minus f of a, that is mod of k minus c. And left jump is mod of f of a minus 0 minus f of a, that is mod of p minus c. Okay, so this type of discontinuity is called jump discontinuity at x equal to a, and this is the right jump, this is the left jump. And the jump, the amount of jump is also called saltus. If f of a plus 0 or f of a minus 0 tends to infinity or minus infinity, this is also tends to infinity or minus infinity, then this type of discontinuity is called infinite discontinuity. If we take fx equal to 1 by x, and now limit x tends to 0 plus fx is equal to infinity. Also limit x tends to 0 minus fx is equal to minus infinity, and we say that this function has infinite discontinuity from the left and from the right also. Similarly, if we take fx equal to x square, then both the limits are infinity. So here is also infinite discontinuity from the left and from the right at x equal to 0. If we consider the function fx equal to e to the power 1 by x minus a, and at the point x equal to a, then we know that limit x tends to a plus fx is equal to limit x tends to a plus e to the power 1 by x minus a, and this is e to the power infinity, this is infinity. But limit x tends to a minus fx is equal to limit x tends to a minus e to the power 1 by x minus a, this is e to the power minus infinity, this is 0. So this function has infinite discontinuity from the right but not from the left. The first kind of discontinuity, if f of a plus 0, f of a minus 0 both exist and this is equal but this is not equal to f of a, then this type is called removable. But if f of a plus 0 and f of a minus 0 both exist but not equal, then this type of discontinuities are called non-removable discontinuity. If we try to remember together in a diagram or in a table, then we can remember easily by the table as discontinuity. There are first kind, second kind, infinite, and oscillator. And first kind have also two types. First type is removable and second kind is non-removable. Okay, and the example of infinite is e to the power 1 by x minus a. Example of oscillator is sine of 1 by x or cos of 1 by x. Example of second kind is also sine 1 by x or cos 1 by x. Example of first kind removable and non-removable. First kind is x square minus 4 by x minus 2, and I think second type is box x. If we take x equal to 1, then limit x tends to 1 plus box x is equal to 1, but limit x tends to 1 minus box x is equal to 0. So these two are exist but not equal. So this is non-removable. So this is the today's class, and this is the table form of type of discontinuities, and we easily remember by this table all type of discontinuity. Okay, thank you for watching.